This is going to be 3.7. Inverse functions. Inverse functions. And like I said, we have one day of this lesson. If we can get it all done today, great. If we have to finish it up tomorrow and then have the rest of the class period as a work day, okay? But at the very most, all we'll do today and tomorrow is this lesson. Cool? Inverse functions. Okay. So, what you have seen before is, I kind of showed you a video of like a function machine, where if I put x into the function, it outputs f of x, right? Input, output. Well, the way inverse functions work is backwards. If I put in f of x, I should output x. It's just backwards, okay? Inverse functions, they're not reciprocals. So we write an inverse like this, f to the negative 1 power, it looks like. F to the negative 1 power. It's actually not being raised to the negative 1 power, but that's what it looks like. What we say here is f inverse of x. F inverse of x. F inverse of x. This is not 1 over f of x. It's not a reciprocal. Not a reciprocal. That's not the relationship that we have here. It's the inverse. Okay. One thing that is kind of cool is if I have two functions, f of x and g of x. F of x and g of x are inverses of each other. Are inverses of each other if their composition, so when I tuck one equation inside the other and simplify, do y'all remember compositions? We did this on 3.4. If the result of the function's composition is x, that's how I know that two functions are inverses. If when I compose them one inside the other, I get x, I know they're inversely related. And we'll do some of this today. This is the rule. Maisie, where have you seen this before? Are you in college algebra right now? Or, no?
We did it. We did like an example of it.
Oh, we did.
Where like the G and F were switched and they had to equal the same thing.
Had to equal the same thing. Try to see if they were commutative, to see if they equaled the same thing. Okay, so what the rule here is if their compositions equal x, then I can tell that f and g are inverses of one another. Okay, so let's dive into a few examples. Mason, are you good?
Yeah.
Did you get all of that? Yeah. Okay, so here's example 1. If f of 2 equals 4 and f of 5 equals 12, what are the corresponding input and output values for the inverse function? If f of 2 is 4 and f of 5 is 12, then the question is, what are the corresponding input and output values for the inverse function? So let's start off with f of 2 is 4. What this means is when x equals 2, comma, y equals 4, right? That's what that says. F of 2 equals 4. When x is 2, y is 4. Well, f inverse of 4 is, anyone want to take a guess? 2. So I basically flip x and y. Switch them. They work backwards. Okay, so when x is 5, y is 12, what is f inverse of 12? 5. So the question is, what are the input and output values for the inverse function? Well, let's call f inverse g. F inverse of x equals g of x. Let's just give that function a new name. So the input and output values for g are going to have when x is 4, y is 2, g of 4 equals 2, and g of 12 equals 5. That's what it wanted. It said, write a new function that's equal to the inverse. And what are its input and output values? So you just flip them. If on my function, x was 2, y is 4, then on the inverse function, x is 4, y is 2. Same thing, when x is 5, y is 12. On my inverse function, when x is 12, y is 5. Good? Any questions there? No? Okay. All right, example 2 has us test inverse relations algebraically. Example 2 says test inverse relationships algebraically. So what the question is here is, when I compose these functions, do I get x? If we get x, they are inversely related. They are inverse functions. If we don't get x, then they're not. Okay. So our two functions here are f of x equals 1 over x plus 2, and g of x equals 1 over x minus 2. So two separate functions. And we're going to try them. Let's do f of g of x, which means I'm going to start writing my f sentence. 1 over x plus 2. You'll see it? 1 over x plus 2. But instead of x, I'm putting in g of x. You'll see what I'm doing here? G of x says 1 over x minus 2. So we plug that in. Well, let's simplify. I've got 1 over x minus 2 plus 2. What happens with the minus 2 and the plus 2? They cancel. So I end up with 1 over x. When I divide by a fraction, I actually multiply by its reciprocal. Well, what's the answer to 1 times x? X. Do you see how the composition led to x? What that means is these are inverse functions. F of x and g of x are inverses. Now, what if you had gone the other way? Is it possible? Can we write g of f of x? If one is true and you get x, the other is true. You would also get x here. But just for kicks, let's try it one time. So g of x is 1 over x. 1 over x. But instead of x, what am I putting here? 1 over f of x, which is 1 over x plus 2. You see how I replace this x business with f of x down here? And then how does g of x finish? Lots of us miss this on our test. You didn't finish the function. Mason, can you see?
Yeah.
So this piece down here of fraction is actually f of x. And g of x says take 1 over f of x minus 2. Okay, so now let's simplify. In this first piece, 1 over x plus 2, well, I'm dividing by a fraction, so what could I actually do instead? Okay, so I'm going to have 1 times x plus 2 over 1 minus 2. My 1's cancel. I got x plus 2 minus 2. 2's cancel. And what do I have? X. They're inversely related. So your composition works both ways. You could test both. You could test the first one. If you can tell that they're not inverses, test the second one just to be sure. But if you get that one composition leads you to X, then the other one also will. So you can say, yes, they're inverses. Okay, so let's go on to example 3. Are y'all doing okay today? I know we're kind of blowing through this pretty quickly, but what? You can go so fast. Okay, so here are two functions. F of x equals x cubed, and g of x equals 1/3 x. The question is, are they inverses? Are they inverses? So how can we test? Right? Tuck them in. Find the composition. So composition here would be f of g of x. F of g of x. So f of x is x cubed. So I'm going to have something cubed. What gets cubed here? G of x, which is?
1 over 3x.
Good, 1 over 3x. They're livening up. Okay, when I cube this function, I cube both pieces. Cube the 1/3. That's going to be 1 over 3, 9, 27. Good girl. 1 over 27, x cubed. Well, is that x? No, not x. So my gut's telling me that these are not inverses. Check the other one just to be sure. Doesn't ever hurt to double verify. So we got g of f of x. What does g say? 1/3 times x cubed, because that's what f of x is. 1/3 times x, and we're replacing that x with x cubed. Is this x? No. It does not say x. That says 1/3 x cubed. Not x. So I agree. Not inverses. Okay. Well, this leads us to a new question. How do I find inverses? If I can tell that these are not inverses, how do I find the inverses? Do you understand what we're saying here? Okay, so we'll just write down some stuff. Would that be okay? To find a function's inverse. To find a function's inverse, comma, or colon. This is a how-to. You're going to do two things. One, we swap x and y. Swap x and y means switch places with my x number and my y number. swap x and y. The second thing we want to do is solve for y. So we're going to flip x and y, and we want to solve for y. This is how we find a function's inverse. So on the last question, we had these two functions. We said, are they inversely related? No. Now, we're going to make inverses. You with me? So this is example 8. And it says, solve to find the inverse function. If f of x equals 2 divided by x minus 3 plus 4, find f inverse of x. If f of x equals 2 over x minus 3 plus 4, find f inverse of x. So we're going to do two things. We're going to swap x and y. You realize that f of x is the same thing as y? Do we know that? So I'm going to write x where y was. And in my equation where I had x, now I'm going to write y. Swap x and y. And then we're going to work backwards to solve for y. Get y by itself. So what's your first move here? Subtract 4. So x minus 4 is equal to 2 divided by y minus 3. And then what? How would you get that y minus 3 out of the denominator? Multiply by it? Not by 2.
And then by it.
By it. Multiply by that y minus 3, and we can cancel it off the bottom. So on the right side, we'll have, left side, y minus 3. Are y'all following this? So we have y minus 3 times x minus 4 equal to 2. Anybody have any guts about what to do next? Any gut instincts? What's happening between this y minus 3 and this x minus 4? They're being multiplied. So if I want to break them apart, what could I do? Divide by the one that I don't want over here. I don't want that x minus 4 on this side. That'll cancel him off. So y minus 3 equals 2 over x minus 4. Add the 3. So y is equal to 2 over x minus 4 plus 3. Because this is the inverse function, we want to go one more step. We don't want to just call it y. Y was this guy, f of x. What we want to do is we want to call this y value, or y equals f inverse of x. This is the inverse function. And there's our answer. F inverse of x equals 2 over x minus 4 plus 3. Okay, that's kind of out there. You want to do one of these from your homework? Say yes. Yes, okay. So one from your homework that I think would be useful to do is number 12. 12's harder than 11. So 12 says f of x equals 2x plus 3 divided by 5x plus 4. This is what f of x is. And they want us to find the inverse function. Find the inverse. So we got two steps. Switch x and y. And then what? Okay, we did. But in that process, what are we trying to do?
Solve for what?
Solve for y. That's what we're trying to get. We're trying to get y by itself. Look at these guys. So we're going to switch x and y. So instead of y equals, we're writing x equals 2y plus 3 divided by 5y plus 4. Switch x and y. And then Zaylee said our first move here is going to be multiply by the denominator. Yes. Push that denominator to the other side. 5y plus 4 times 5y plus 4 on this side. And now I have 5y plus 4 times x equal to 2y plus 3. Can you see that I have y's on both sides of my equation? Yeah? Okay, so what we're going to do is we're going to push this x through the binomial. We're going to distribute the x. Do that first. It's a monomial. On the last problem, freeze. Look at the last problem. Right here, we had x as a binomial, and we were able to divide it off because on the other side, I didn't have any y stuff. On this problem, I have y stuff right here. So it's not going to be helpful to divide by that x at this point. I'm still going to have y over there to deal with. Do you understand? So we're going to push this x through. That's going to make me 5xy plus 4x equal to 2y plus 3. Now we can get all of our y stuff on one side and all of our other stuff on the other side. Okay, this is a really crucial set of procedures. We do this in pre-cal, those of you who are headed that direction next year, and we do this same thought in calculus. So this movement of variables across equals, this holds. You got to know how to do this. We want everything that says y to push to the left. We want everything that says x to push to the right. So I'm going to have 5xy minus 2y equal to negative 4x plus 3. Okay, I didn't show that algebra, but when those two variables cross equals, they change signs. Are y'all with me? The reason that we put all of the y stuff on this side is now I can undistribute it. I can take it back. What's the F word that talks about undistributing? Factor. I can factor out, I can factor out the y. You following that? So when we pull that y value out, what's left? Yeah, we're pulling that y out to the front. 5x minus 2 equal to negative 4x plus 3. Not subtract it, it's y times it. Divide by it. Divide by the 5x minus 2. Good. So y is equal to negative 4x plus 3 divided by 5x minus 2. Instead of y, we want to go to f inverse of x is negative 4x plus 3 divided by 5x minus 2. That's how you write an inverse function. Who's here tomorrow? Who's not here tomorrow?
I don't know yet.
Not here tomorrow. Okay. I'm going to stop right there because I think that there's just more here than we're going to have time for today. But if you're not here tomorrow, just stay tuned and watch on YouTube, okay? It'll probably be 15-20 minutes of lesson tomorrow. But y'all are dead right now, and I don't want to keep frying you. So we'll finish this lesson tomorrow. Okay?